right. Hi, everyone. So my name is Nicolas. I'm the tech lead on the design tools and constraint layout at Google. And I guess I'll ask first, how many of you, let's start broad, are Android developers? Oh, OK, there's most of you. How many of you have used Android Studio and constraint layout? All right. How many of you have used Android Studio 3.0? All right, OK. Hopefully you learned some things. All right, so let me just talk a little bit about constraint layout. And first, about Android layouts in general. So what is it that we want to do with layouts? Easy, we just want to move stuff on screen and position them where we want them to be. The difficulty, well, it's Android, right? It can be anywhere, so you need to have something, some kind of method that will work, whatever is your screen size, language, the density of the screen, and etc. And traditionally, Android layouts are pretty focused into what they do, and you manage to do your layouts by combining them, nesting them, and coming up with your final screen. Enter constraint layout. Well, what we did is basically the complete opposite of that. We try to have a layout manager that's very expressive, where you can basically do anything you want in terms of screen and still get a responsive screen. The other key idea is to try as much as possible to have a flat layout. And I'll explain a little later why it's kind of nice. It's also deeply integrated with Android Studio. It's literally the same team that works on both projects, on the layout editor in Studio and on constraint layout. It's an unbundled library, meaning you can update it in your project when you choose. And on our end, we can push new version whenever we want. So that's kind of nice. And it's compatible API 9, so basically everywhere. So, typical Android layouts. And I'm sure you look at that, it's like, wow, a bunch of nested relative layouts, is that really typical? Believe me, it is. I've seen way worse. And it's not that crazy if you look at the way it's cut. But if you look at layouts versus the widgets, the stuff that are displayed on screen, you see that the layouts are in red. There's a lot of stuff just to decide where those widgets are going to be. If we flatten that, that's kind of what you see. And well, I call that the Tetris model, which is basically something that's relatively easy at first. Everyone understands linear layout. How hard can it be? I take one element, put it after the other. But it can get very complex very quickly. Specifically, you tend to nest a lot of those layouts, and you end up with something that's deeply nested, deep hierarchies. One of the issues is that it becomes your layout becomes pretty static, not in terms of how it reacts to the screen, but in terms of if you want to do changes to that layout, it becomes increasingly hard. It's also not conducive to a great design experience for this exact same reason. If you decided that your button actually shouldn't be where you put it at first, you can't simply move it around. You have to untangle it with the rest of your view groups, and that can be pretty annoying. Finally, there's also a question about performance, even though I'd say with more recent VMs and more recent fonts, it's less of an issue than it used to be. It's still something that you should keep in mind. So ideally, if we look back at this screen, we'd like to get rid of everything that's in the middle. That would be nice. And in fact, what I'd like is to move all the widgets on one end, and all the layout information on the other side. In some ways, what I would really like is to be able to say, the layout, the rules that position your widgets should be actually completely separate from your views. And that's what I've been talking about. That's what I call flat layouts. It's not mixed with the view hierarchy. You want to keep it separate. What that allows us to do is to manipulate this structure in a much nicer way in the graphical editor in Android Studio. It's much easier to change. Your stuff are not tangled within that net of layouts. You can just take your button and move it everywhere else. It's also animation friendly because, well, You don't have to worry about clipping or anything like that. If you are deep down in the hierarchy, it just works. And lastly, it also keeps all the computation of layouts into a single place, which I mean, you may not care too much, but I care. And that should allow us to do some nice performance improvement in the future. So basically, that's what we get if we move that previous screen to this new constraint layout stuff. We basically keep only the views in the view hierarchy. All the layout rules are just part of the layout attributes. Purely in terms of performances, we actually get a slight bump compared to the previous screen. You can find on this URL some Google DevRel published performance analysis. It's pretty interesting, not so much, I would say, even for the results themselves, but by the methodology that he took. It's something that you can reuse in your own program in order to figure out what's going on. So if we want to do that, if we want to get this layout, what do we need to do? We want something that's really expressive, right? Because that's exactly what I'm talking about here. We are not saying just solve layout for this particular corner case. We are trying to come up with a solution that works for any type of layout, where ideally you could just express any layout. So we come up with this idea of, there is this idea of a linear solver, right? It's a very brand new idea, I'd say, because it got invented by Danzig in 1947. That's linear programming. Basically, you express your problem in terms of linear equations, generating gigantic matrices, and you try to optimize your goal for that problem. So that's a typical example of how it looks like. You have your linear equation. Everyone remembers those, hopefully. They are constrained. As a constraint expressed as a linear equation as well. Put that into a matrix. Find a startup solution, like the basic feasible solution, and then you just iterate on the problem space until you find your best solution. So that's great, right? There's a couple of pros and cons. One, sure, it's very flexible. You can represent any type of layout that you care, as long as you represent it as linear equations. It's also a little more heavy computationally compared to, let's say, linear layout, right? Now I have to create equations and solve them. Also, could be more memory intensive for the same reason. And finally, I'm sure that when you'll tell your designer that they suddenly have to write equations, they'll love you back. So what did we do for constraint layout? Well, we got an implementation, we created an implementation of the solver in pure Java so that it's easy to distribute. Everything is presented as sparse array for the matrix, so it's pretty memory efficient. It's an incremental solution as well, which is basically we try to optimize for the cold case. And it had to have good performances both on Dalvik and Art in terms of the VM. But more importantly, or more unique compared to other systems that follow a similar approach, we come up with a constraint model. And the idea here was to come up with a very simple model, something that maybe not be as powerful as if we gave you access to the entire equation solver, but would be still better than what you had before, at the same time simple, easy to understand. So that was the idea. And we don't want to expose the equation because we thought, that may not be conducive to the best experience as developers. The nice thing is, it is evolving. If you followed the progress on constraint layout and the various releases that we made these past couple of years, there is a bunch of new features that we gradually added. So it's kind of like we are starting from a pretty closed form model, pretty set up in a way, and then we gradually open it up a little more. And fundamentally, the model we took is this one. You got a system with anchors, typically the left, top, the right, the bottom. You also have baseline for the text. And the gist of the idea is that you say that you have a source anchor, and you connect it to a target anchor, and the source anchor has to be at the position of the target anchor, modulo margin, right? And this is exactly what we're doing here. You see I'm setting up this button relative to the other one. When I move the other one, the first button moves along. Very similar to relative layout in concept. Nothing too surprising here. But we did an extra thing, which was the ability of centering stuff by pointing the two opposite anchors to different targets. And here you cannot just simply say, well, my original source target is going to be at this position and the other one as well, but because if your widget is fixed size, that's not possible. It's one or the other. So we decided in that case to just center it. And that's basically how you center stuff in constraint layout. It actually works the same if you connect both, let's say here the left and right. You can even center it on the same anchor. It will just center the widget relative to that anchor. It doesn't have to be the parent. It can be any anchor in the system. And finally, the last thing we added on this very basic model is the ability of having a bias, which you should see. And fundamentally, what that's saying is that, well, you might be more biased toward one side or the other. And that's it. Fundamentally, that's constraint layout. If you understand that, you understand constraint layout. All the rest is extra features that we added, but that is the basic model. And that alone allows you to, for start, do everything that relative layout was doing. It's completely a superset. Plus, you got extra flexibility with the centering to create way more flexible UI that way. Another thing we did is because we've got this constraint model, we can easily optimize stuff before even going to the solver. So in some ways, of course, we have some optimization in the solver, but if you start optimizing at the solver level, you're a little late in many ways. And because the constraint model is sitting a little higher up than that, the optimization you can do there, you have more information to do interesting optimization. So we are taking strong advantage of that to keep the performances pretty good. A couple of things to keep in mind. Well, like on linear layout, if you use 0DP, what we call match constraint in the constraint layout world, we measure the widget twice. So that's more costly than if you are setting your widget dimension to be wrap content or fixed dimension. In a sense, the fixed dimension or wrap content, they're equivalent as far as the solver is concerned. It just says, well, my widget has a specific size, and we go with that. The other thing is, if you follow what I said about connecting to those anchors, if those anchors you connect to are themselves fixed, or they can be by derivation, calculated or computed to be fixed, that's also very fast. So typically, if you're using guideline, for instance, that's pretty fast. It all breaks if you are using stuff like wrap content and a percentage guideline, because then we don't know the percentage of the container before we compute the wrap content and stuff like that. So in some situations, we escape to the solver and we just have the solver solve the complex equations. But in a lot of situations, we are able to just derive the right solution straight away. And that's kind of the nice thing with this model, is that we have a very mixed model. Part of the system, like the solver, is not just all or nothing. You might very well have 80% of your system being solved straight away with no solver input. And the last 20% that for whatever reason we can't solve, we just ask the solver nicely. And that's a really nice model that feeds on itself. So every optimization we do helps the solver as well. All right, so that hopefully gives you a rough overview of constraint layout. Shouldn't be too new for most of you, apparently. Now let's talk a little bit about Android Studio. Because as I said, we're trying to develop both projects, the designer in Studio and constraint layout, kind of along. So we did some things in constraint layout to help the layout editor, and sometimes the other way around. So what do we do with a visual designer? Well, we want to visualize stuff. I know. And basically, we just take your XML file, we run it through something called layoutlib, which in a sense, it's a port of the Android framework, the UI framework, on desktop. It runs on the Java desktop VM. What's really nice with that is that it means that we just don't work for, let's say, just constraint layout or just whatever layout we are using. It works with everything. So it means it works with any library, external library that you want to use. It works with your custom views, your custom view groups, whatever. We just run the same code. The other advantage is that when you run constraint layout, for instance, Studio doesn't have its own version of constraint layout. It just gets the version you are using in your application and runs it. So we pass that through layoutlib, and that ends up being rendered into the layout editor. A couple of the other things that we do, of course, in the Visual Designer is a bunch of features to help you create those layouts. And finally, we are trying to make it as easy as possible. So the layout editor, very straightforward. You have this center area that we call the design surface. You got an area this is where you get all your widgets and containers and whatever that you want to drag to the design surface. You got an area showing the structure of the XML file, and you can use this area to actually reorder things in the XML. You don't have to go to the XML to do that. You can also drag directly from the palette to the component tree. So it's pretty flexible. And you also then have an inspector that shows you attributes for the widget you are selecting. And if you notice as well, on the component tree, we now show you the warnings and errors. So if you have lint check and whatever, that's an easy way to see that your layout is correct. Pretty straightforward. The other thing that we do within the layout editor is that we show you another way of looking at your UI. The previous way with the images and stuff, it's called the design mode. This mode is called the blueprint mode, and the idea is that we care more here about the rules, the constraints, than about how it looks on your device. And you can have both at the same time if you want. Another mode that I am sure a lot of you are using is the XML editing mode. And if you don't know, in the editing mode, in that mode, you can actually pull up a preview pane. And that preview pane not only shows you your layout, but you can actually also just use it. It's the full-blown editor. So you can do everything you can do in the normal design in the layout editor. You can do it from XML as well. If you click on something in that editor, it will go at the right place in the XML and vice versa. So you can see, drag something there, it appears in the XML, everything is in sync. See? All right, so we then have a bunch of tools in the layout editor. And that, maybe we're maybe starting at the point where maybe some of you haven't looked at all of those tools. I'm not going to cover all of them in details, but basically just know that, particularly if you haven't played with them, you have a bunch of tools if your layout is constraint layout that allows you easily to create constraints, to position those elements, center them, create chains, if you know what that is, etc., etc. Create guidelines, which are those helpers, objects, etc. We move on the inspector, showing you both a representation of the constraint for that widget, hopefully in a sometimes clearer way than what you can see in the design surface, as well as a series of attributes. You can also have what we call the full inspector, showing you all the possible attributes. So if you don't quite know what you're looking at, you can either search or just scroll to find the attribute you want. And finally, in Android Studio 3.0, we introduced a new mode that functions a little bit differently for the inspector. So the idea is that, in general, for your layout, you don't have just one layout file, right? You have daemons and strings and stuff like that. And in fact, your layout is more like the intersection of all those files rather than one single file. So ideally, you'd like to get a bit of that and this and that, gather everything in one place to really look at what's going on in your layout. And this new mode in the inspector basically allows you to do exactly that. It shows you your attributes the same way that it shows you in the XML, so you don't get lost. You got auto-completion. Everything works, and it shows you the elements that are referenced just below so you hear that's your main file, for instance, and you got the various elements that are referenced are just shown here, and the title is the file they are coming from. The other thing is that it only shows you the one widget you are selecting, which can be a little faster than if you go back to the XML mode. Another tweak we did in Android Studio 3.0 is those little plus buttons in the inspector. And basically the idea is that, well, the inspector is here to show you the constraint, but sometimes it would be nice to be able to create constraints. So what that does, when you click on one, you just create a constraint by, in essence, we cast array, and whatever is the widget we hit first, we create a constraint on it. And by default, we'll set it to the margin of that constraint will be the distance between your current widget and whatever you hit. But because in the inspector you can easily change that margin to whatever other value you want, it's pretty convenient. And finally, we have this pretty good inference mode that we actually improved quite a bit in 3.0, where you can start with a screen like that has no constraints whatsoever. Press one button, and all those constraints are generated. And it actually works pretty well. It's a probabilistic model. We are improving it over time. And what's pretty nice with it is that it only works on stuff that are not created yet. So you could start with setting up a couple of constraints that you think are the right constraint for your layout. And for the rest, just press the inference button, and whatever is left to be constrained will be constrained. So quick video on how all of that works together. So here I'm just selecting those buttons, creating an horizontal chain. I'm aligning them all together vertically. And now I press the inference button, and you see that there's only one constraint being created because, well, all the rest was already constrained. But basically, it's not going to override my constraints. It's going to try to work with whatever you did. So that's the inference mode. A couple of useful shortcuts you may not know that are pretty convenient when editing layouts. Specifically, ESC to select your parent is always nice. You can easily switch between XML and design mode. And if you have an included element in your layout, which is pretty common when you are complex layouts, just double-click in the component tree. You can go back and forth whatever you included. Another thing we added or more exactly we extended in Android Studio 3.0 is like the tools attributes and the sample data. So tools attributes are a bunch of XML attributes that, in a sense, are here to override whatever attribute you have. That's pretty convenient if, for instance, let's say you have a text view. You put in your layout, and actually the content of that text view is not indicated by Android:text because you are doing that by code. It may come from whatever database or something like that. So you can instead use tools:text and specify some random text that you just use within the context of the layout editor, and we'll just use that value when we render stuff through layout lib. So that's kind of nice if you just want to edit stuff, even though the actual real application will just set those values themselves. And there's a bunch of other attributes that are pretty useful. Specifically one, I don't know if you know about it, but if you don't, it's really cool. It's tools:list item, which allows you to, if you have a recycler view or a list view, to set up to reference another layout that you will then use as the row in your layout. So if we start with a recycler view like that, that's what you see by default. We have a random default adapter that is not great, right? It just shows you those 9 or 10 elements and not doing much. So by using the tools list item, you can specify the content, and everything looks much nicer. And that you can imagine in a more complex UI that gives you a much better feel. But one thing we added in 3.0 is the concept of having sample data. Because if you look at that, sure, yeah, that's nice, but that's not how my application will look like. It's not text view and some random color. I want more. So with sample data, you can basically add, reference some data that we pre-baked in Studio. So for example, here, you can indicate full names and US phones, and automatically, sorry, in the adapter, we will show you those elements. It actually goes further than that. You can create a sample data folder in your project. And let's say that here, I'm going to create a color file, which is just a plain text file with a list of hexadecimal colors. And then in my XML file, I'm going to reference that. And then automatically it will just pick those colors. And sample data goes further than that. If you want to use lorem ipsum, for instance, just reference the sample lorem, some random dates, the colors. You can even create JSON files to contain structured data and reference those structured data within your layout. And that works, of course, in the context of this adapter in Recycler view, but that also works in any layout. So if I just even have a text view that's just a text view, I could also put some sample data there. That's no problem. So you got some baked-in data type, the JSON files as mentioned, and also the resources in that sample data folder. So with images, for instance, you can put them into a folder. If you have more than one image in that folder, that will be treated as a collection that we can then reuse, let's say, in Recycler view. All right, going back to constraint layout, now that you saw a little bit how everything is tied together in Studio. So when we announced 1.0, or more exactly, when we released the final version of 1.0 early this year, this is the set of features that we offered in 1.0. So we had relative positioning and center positioning and bias, which, as I said, basically that's what constraint layout is. We also had guidelines, chains, and min-max and ratio, and constraint set. So guidelines is pretty cool. The idea is that, well, we could provide you with tools, helpers object, that lets you create your layout, even though ultimately those guidelines are not going to appear on your screen. They're just here to help you create the layout. So a guideline is what your designer called key line, red line, basically just vertical or horizontal line that you can position relative to one side or the other, or as a percentage. And you can set up your elements relative to that baseline. The other thing that we had was the concept of chains. And chain is basically the need to have some kind of group behavior while not having to introduce another view group. And we do that because we wanted to keep things as flat as we could. And the way we specify that is simply if you have at least two elements that have basically a bidirectional constraint. So one is connected to the other, and the other is also connected to the other one, and that's it. That's a chain. So you have different type of chain. Specifically, the default one is spread, so all the elements are just going to be spread apart. You have spread inside, which is simply where we cut off the end. And you can also use the weighted mode. If you set one of the dimension of those widgets to be 0 dp, it's going to take whatever space is left. And if two elements have 0 dp, well, they will share it equally. But if you specify the weight, then et cetera, et cetera. So that's very similar to a lot of the concepts you're already using in other Android layouts, just everything's kind of coming together. And the last one is packed, which is kind of nice just to consider all those widgets in a chain to be part of the same group, and you can then center the entire group, not just one widget. And bias works as well. And finally, the one difference, the pretty important difference compared to, say, linear layout, is that chains only work in one axis, horizontal or vertical, meaning that you can very well define one chain horizontally for a group of widgets, but vertically having them being constrained in a completely different way. While with linear layouts, by definition, it has to constrain both dimensions. So another thing that I don't know if lots of people realized what you could do with, but that's, I think, pretty nice, is the ability of reacting differently when a widget is mapped as gone. So if you remember on Android, a widget can have three states for its visibility, either visible, invisible, meaning that it's still there, it's still participating into the layout, it's just not drawn, and gone, it should not participate into the layout. Well, if you have some experience with relative layout, you know that if you set a constraint in relative layout on an element that happens to later be gone, things don't go too well. With constraint layout, we try to actually take in account this use case. So what happens is that an element that is marked as gone, its size is set to 0, 0. Its connections are still valid, but the margin is set to 0. And basically, you end up with this behavior. So if the central button here is marked as gone, everything will collapse, but kind of nicely. Sometimes that doesn't work so well. If the first button does that, all the second and third button are moving in position that maybe that's not what we wanted. So we added concept of specifying margin that are only applied if the target happen to be gone. And in that case, you can control this behavior. So the second button had a margin of 0 originally, but if the target it's connected to is marked as gone, then it becomes 32, so everything stays where we want them to be. And you can just use all of those to do pretty nifty stuff like that without having to recreate different layouts. You can, it's a pretty flexible way of organizing your layouts. So, just before I/O, we announced 1.1 beta 1. We are now at beta 3 that we shipped last week. What do we have in 1.1? We had one big feature that we call the barriers, which essentially is here to take the upmost side of a set of widgets. So whichever widget is, let's say, here the rightmost, the barrier is going to be positioned there. And so it's very convenient when you have elements that you don't know automatically what size they will be. You just want to be sure that you constrain another element after those. So in a more logical or more common example, you have like something like that with those 3 text fields. You want that icon to be on the right of all of that, but maybe the title will change. So the constraints here are pretty straightforward. They're all centered to the guideline, actually. And the guideline is just this dotted line here with all those elements being part of the guide, of the baseline. Barriers. And that icon is just constrained to the barrier itself. So if now the element 1 changes size, what we end up having is simply everything collapse nicely. So that's a very powerful concept. It's one that we were a bit too tight to integrate into 1.0. But I think with its inclusion in 1.1, we kind of, that's the last big concept in terms of being able to organize your layout. And how you specify that, it's pretty straightforward. You indicate a direction, could be start, end, left, top, bottom, and right, and you contain the list of IDs. So the element you are constraining there, or you are constrained to, needs to have IDs. We also introduce groups, which is kind of a shorthand to set the visibility on a group of widgets, so that basically you can set up that group in your XML editor rather than having to maintain a group in your code. So same principle, you have the visibility attribute here, but the constraint reference IDs works the same way as for barrier. And so example on this one, on the left, that's what happens if this group is set to invisible. On the right, what happens if the group is set to gone? You see that both elements are marked as gone and everything collapses with the same rules we just explained. We also introduced placeholder, which is basically placeholder is here so that you can set up a placeholder like any other view, but it's not going to contain anything. And you can then specify an ID of another view within your layout that will be the content of that placeholder. And what happened to that original view and whatever rules were controlling that other view, that view will basically behave like if it was set to gone in its original position and kind of translate it back to where the placeholder is. So you can do some nifty stuff like this, for example, where I just can easily move back and forth an icon from one place or to the other. We also added percent dimensions. So percent dimensions is the ability of setting the dimension of one widget to be in percent. It's very complex. It's only relative to the container itself. And the way you set it is just by setting layout constraint width or height underscore % and some float. And you have to set the Android colon width, Android colon height, layout width and height to 0 dp. Finally, with beta 3, we added circular constraints, which is just a way of constraining one widget relative to the center of another widget with an angle and a radius. The attributes are pretty straightforward here. You can do some nice things like, for example, like a pie menu or circular menu like that. And there is like, Andrew Kelly did a nice little animation like that. Should have done ellipses. So you get 1.1 simply using Maven, and that's a big step. Before, with 1.0, we were shipping constraint layout as part of the SDK manager in Android Studio. Now, we are good citizens, we are using Maven. So if you don't know, you should know that, because it currently is not going to tell you that there's a new version, because we are still checking the SDK manager until we release 1.0 final, and that should be the one being picked up. But until then, you'll have to add it yourself. If you are not using 3.0, you have to add Maven URL, maven.google.com. If you're using 3.0, you shouldn't have to do anything. There should be like a Google keyword somewhere, and everything should just work. All right, let me cover a couple of case studies on how to use or better use a constraint layout. So I've seen this use case a few times, where you got a bunch of text views that are constrained one to another, and specifically the baselines are constrained one to another like that. And well, there's no problem with that. I mean, it works perfectly fine, unless you decide to have like the middle widget number 1, you decide to set it to gone. In that case, the baseline is not going to be where you want it to be, and the text view, like the widget number 2, is not going to end up where you want it to be at all. So in those situations, the simplest is just think about it. You could just set all those baseline constraints to the one element that's not going to move. Another example of things that it's common to get wrong or to not think about with constraint layout is, well, imagine this row layout. Pretty straightforward. This is what I would do for the constraints. We could do it differently for those text view at the bottom and at the top. Here, it just happened to be different separate text view. There could be one single text view. And you got this short title that's connected to the left of the first one. And at the right of my row, I got this image. So looks right, yeah, it looks fine. Well, until you happen to have a title that's going to stretch too far, and you end up with this, which is probably not what you want. So how to fix that? It's actually not too complicated. You just need to add a constraint from the title to the icon. But there's a trick here. One is that's going to set up a center connection. As we said, if you've got two opposite constraints, it's going to center. So if you do that, you have to remember to set the bias to 0 because you want everything tacked to the left. And the last thing is, right now the dimension in width of the title is basically wrap content. We just ask the title, give me your size. But wrap content, as I said earlier, it's going to be handled by constraint layout as a fixed dimension. We ask the widget, what's your size, and we don't care about it afterward. And if we are going to slam into constraints, we don't care either. It's mostly for optimization purposes because most of the time that's actually what you want. But you've got some situations like that where you actually wanted to apply the constraint. So we introduced something in beta 2 or beta 1, I don't remember, that was trying to work around that by using 0dp and a specific mode to handle the constraint as wrap. That happens to not work because there is a nice optimization in text view that was trying to be too clever. So in beta 3, we had to walk back that method. So now the recommended way is you keep things as wrap content for your title, but you add layout constraint width equal true. And what that means is that, sure, we'll ask the widget to be wrap content, but at the same time we say, oh, but just make sure that you're not going to overrule some constraints. And that works really well. Everything's going to wrap correctly. Another example that I saw a few times where you have this situation. You have some bit of text, the text can grow, you want to attach something at the right of that text, but you don't want to go too far. You want to keep it in the container and maybe to, like in that case here, I'm ellipsizing the text, but how do you do that? It's kind of the similar approach than the previous example, but here we create an horizontal chain between the widget number 1 and number 2. It's a packed chain, so they will act like as a packed group. Set to 0 because we want things to be on the left by default here. And finally, on that first widget, we also say, make sure to respect the constraints. And then everything will just work correctly. So that's it on the kind of the little tips here. But there is one thing I saw a few times as well, and that's one is a little strange to me, but basically, we've been telling people, yeah, flat layout, you should do that. And yes, indeed, you should do that. But at least in my mind, it's more about you have a set of components that you then want to position wherever you want in your flat layouts. But those components, sure, they are, that start with the widgets, but you might also have components that are a little more complex than just the widgets. As long as, in some ways, they are high-level components, I think it's perfectly fine. In fact, in my own personal project, I often do that. I have some parts of my UI that are components, or at least I consider them like components, and they are done with constraint layout, but they are within a root constraint layout because it's much easier to just move them around. So in that example, it's not a component. It's just someone put a view and constrains like an image view and a text view to that view. And not only is it a bit confusing to read, but I'm not even sure it's that performant. In that case, well, you may not need even, in that particular case, you could probably do it with text view, but situations like that, you could simply just use a constraint layout if you really wanted to, but that's all. Another example of using constraint layout in that way, well, those guidelines and barriers are pretty nifty, and you could do grid-based layouts very easily like that. What's nice is that you can just keep the grid just for the part that needs the grid. All the rest, you can just use the relative constraints as usual. All right, so that kind of sums it up for those tips. Let me talk a little bit about constraint set. So constraint set, if you go back to this, what I was showing earlier about, layout should be different from the view hierarchy, right? We want to keep things separate. Basically, the rules, the layout, it's constraint layout, sure. And the views, well, those are the views in your hierarchy, great. Constraint set, it's the part of constraint layout that contains those rules. And what's great is that it contains all the rules applied to a current constraint layout. And you can actually switch them. So you can get another constraint set and just switch them around like that. So it basically separates the views from the rules. You can encapsulate all those constraints into one single object that you can then swap. And you can apply any constraint set to like a constraint set to the constraint layout, and you can just toggle within them. So what are you going to use it for? Well, basically how you create them, it's pretty straightforward. Create a couple of instances. You can create them either by cloning an existing layout file or cloning your current layout. And that's how you get those constraints. How you apply them, just call apply to, and that's it. It's kind of nice if you want to, say, do completely different layouts between portrait and landscape. You can just create 2 layout files, instantiate your constraint set from those 2 layout files, and apply the constraint set. What's nice with it is that you are then in full control about when do you do the instantiation of those constraint sets. So you can make sure that you do that at the right time and not when you want to make sure that everything is smooth. So you can do kind of pre-caching of loading those rules and applying them at runtime. And when you apply them, as long as the IDs are the same, we just apply those rules. We don't reload the view hierarchy. all those views are the same. So that's kind of a nice, powerful idea. But what's something that I'm way more excited about for constraint set is the idea that you can do motion with it, And there's a couple of nice advantages of having this flat hierarchy, right? You don't have clipping issues. You kind of think about the entire hierarchy as a scene graph, and you can think about, let's say, like a couple of constraint sets as the beginning and end keyframe of an animation. And what's cool as well is that how to actually apply those things. If you go back to that example earlier, essentially you just do that line, and that's it. You call transition manager, and all the differences between the two layouts are going to be automatically computed, and the animation is going to play for you. So that's how it looks, for instance. Here I got two layouts. I click on the button, and when I'm in the button handler, I'm just toggling between those two constraint sets. And transition manager does its magic, and everything moves nicely. It was much easier to do that than to do it by hand, believe me. So another example is, just that. Same thing, very straightforward. But here that shows one issue with using transition manager. It doesn't feel very exciting. But luckily, you can define custom transitions, and with custom transition, here we are just using the physics library. Don't do that in your application again, but just to give you an idea that you can customize those transitions relatively easily, so you are in full control of what the transition will be, in which order, etc. Another example, you can set up like the visibility ripple effect, just like that. And again, this is just two layouts. In the second layout, the view happens to be shown, and I just plugged into the transition the ripple effect. All right, so what's next for constraint layout in general and for the layout editor? Well, for constraint layout, it's mostly, we're trying to finish and ship 1.1, mostly about performance optimization. We have a ton of ideas. I'm not sure we'll implement all of those for 1.1, but we should have a good going at getting most of them. Specifically, we have a new optimizer in 1.1 that I'm hoping should be way faster than what we got in 1.0. So we'll see, but pretty hopeful. The other thing is that we have this new concept of constraint helper that we saw with chains, with the guidelines and stuff like that. So we are thinking to do helpers to more easily create chains, for instance, and we have a couple of other ideas. And finally, there's some interesting stuff coming up with motion, I feel. Bunch of documentation. Constraint layout has been documented by a lot of people on YouTube, Medium, various websites. That's a good start, but it's by far not the only documentation. And there is a constraintlayout.com website that's pretty cool as well if you want to check it. But yeah, and that's it. So we have a few minutes for a couple of questions, maybe. Yeah.
I'm very interested in the constraint set as a way to animate and to really have an easier way to declare an evolution in the same layout. Problem I have with it, saying it like that, is if I have a lot of layouts, it's gonna get messy really fast. Mm-hmm. To have multiple layouts from multiple states. Do you plan in the future to be able to declare multiple constraint sets for one layout? To be able to visualize different steps and not get messy with ID differences and stuff?
We have some plans. One thing you can actually do now, in fact, is you can actually set up a constraint set in a separate file. It's just that we haven't turned that on into the layout editor, so you would have to do it by hand. But you can do that if you want to maintain your constraint set separate. But we are thinking about we have a couple of ideas on how to improve the situation. Won't make it for 3.0, but we'll see for 3.1 or 3.2.
Just a question about the nested layouts. How does it behave when you have multiple constraint layouts that you want to reuse in your app?
So, well, in general, it works perfectly fine. The one thing I would say is that there is at least an option for us to do some optimization if you have the situation where you have a constraint layout inside, like the parent is itself a constraint layout. Right now, we are not doing anything special, but we should do it. So at least in the future, I think it will be a bit faster if you are in this situation. All right. Well, thanks everyone. Yeah.